Welcome. Hello, ladies and gentlemen. Welcome to Brompton Technology. Welcome to our little presentation. Today, I want to talk about the future of broadcast. Just a few words about myself. I'm Oliver Dier. I'm working for Brompton Technology in Europe. So, if you're ever over, just let us know. Brompton Technology is making LED processing. We do make the best LED processors for virtual production. We do make the best LED processors for applications in broadcast world. I want to tell you today why. We have won an Emmy last year. We have won many other awards. We see there an award for receiver card. So you see we have a very rock solid reference and history in doing an amazing product which is tailored for the needs for your broadcast and for your camera productions. I'll show you a few things today. First, let me talk what an LED processor does. Well, an LED processor takes your video input, which you need to display on your screen, which you need to make look amazing, and it's basically splitting this video input into chunks, sends it to the LED panels. Inside the LED panel, you have a receiving card. The receiving card is basically your brain of the LED. So it's like a computer. It's taking the information from the video signal and converts that into data which can be read by the driver chips and which consequently drive the LEDs and pulse width modulation. So it's a very difficult, very complex process, so that's why you need a lot of calculation power. We do that. We do that. Card is doing all this calculation power, and we do the processing. And we do a lot of more. We do a lot of software, a lot of features which are tailored for your needs in virtual production. Just giving you an example how all that looks in a context. So that's just a very simple video system example. And you see your camera is basically taking your image. Your camera is tailored with a tracking system to actually move on the LED panel to make sure that you have the right parallax, that you have the right perspectives on your screen. All that information tracking and video capture that goes in the media server. The media server gives the output to the LED processor, and the LED processor, as I explained to you, brings you a nice image on the LED wall. So you see we're kind of at the end of this chain, right? So the camera is capturing something you're going to see again. So if the LED processing part isn't right, well, the camera cannot pick up something which is good. So consequently, the LED processing part need to be as good as possible. And you get that with Brompton Technology. And you get a lot more. So we are used to this. So we are used to our beautiful looking talent in our TV studios, captured by a camera on a nice virtual set, where you almost think, okay, that's the real world. But is it as easy just putting in a laptop and having a real world? No, it's not. It's a bit more difficult. So you need a lot of processing power. You need a lot of fantastic features, which we offer. Just to go a little bit into the history of Brompton, I mean, why we are good at that? It's because we offer rock solid, very reliable products which are used in mission critical installations. Mission critical, just to give you two examples, it's a recent Ed Sheeran mathematics tour. Imagine that something fails on this tour. I mean, like 100,000 people will be very disappointed. So you just can't really do that. So you need a high reliable system. We offer that. The BT Tower is another classic example. That's a landmark in London, can be seen in all city, and it has a screen on top, the little circle. It's run on Brompton Technology for, I think, about 10 years, flawlessly, without any interruptions. I mean, that's an example for mission critical installations. Another very important step which we offer with our processing product is image quality. What do we mean by image quality? We do have a lot of tools to make your image look better. Specifically in low light applications or in low brightness applications on the LED screen, we have a functionality, it's called extended bit depth. So it means with extended bit depth, it's technology which is enhancing the quality, which gives you much more grayscale steps for pulse width modulation, which you need to make a lot of colors and a lot of dynamics. We can offer that. So you see on this example, with extended bit depth, you have an image even on a very low level, which is still smooth, with such a quite nice gradients, without, well, it just look bended. You have, well, not a very good quality. With Pure Tone. Pure Tone is there to tailor not linearity on LED. So LED on a low level is not as accurate as it should be on high levels. So we have a technology called Pure Tone. We profile panels and we offer you a full range and the whole quality and color, stability, and the whole brightness channel. We do have the best on-camera performance. And we not only say that, it is true. We do have specific technologies we can offer to make your camera look accurate on your LED screen. So we have a patented feature, it's called shutter sync. I don't know if you know it, when you point a camera on an LED screen, you can have scan lines, you can have like black lines, black bending lines, just because your camera shutter is working in lines, the LED is working in lines, and if they overlap, that can cause all kinds of artifacts, all kinds of issues. We have a technology called shutter sync, and that makes sure that your camera exposure time of the sensor is being matched to the exposure, to the image exposure of the LED screen. So that means you don't get all these strange artifacts, you don't get all these wrong images, which you don't want. So artifact-free image reproduction, use shutter sync on Brompton processing. You might not even worry about all that because it's all built-in features, they're all active, you just use them and you just never worry about them again. So what else can we offer on top of that? Well, we do offer things like frame remapping. Frame remapping is a great technology for the broadcast sector because it gives you the possibility to blend two different images, two different frustums into one unified image. So that gives you, let's say, a multi-camera production with two cameras, and it gives you two different perspectives, and you always have the same image on the back. I jump now to our live demo. Bear with me, just need to find the right thing. And here we have a frame remapping demo. So what we do here, we do have two different scenes. It's beautiful London, and we have two monitors, and we have a camera. So what is so special about that? Okay, we're sending two scenes, so two images in the same time to the LED screen. The LED screen is run on double the speed, and we're basically producing two fields which are alternating. And each of the alternating frames is being picked up by the camera sensor, which is perfectly synchronized with shutter sync and with Genlock to the LED processor. Consequently, you get two very clean images out of this camera, which is great because it gives us these two feeds. So you have two monitors, and you should be able to see what I see in the back is mixed, but you should see two separate images. So that's frame remapping. Frame remapping can do a lot of that, because it's not only giving you the possibility of having two images. With our new 3.5 software release, it gives you enhanced features. It gives you tracking markers on top. Can you turn on tracking markers, Tom? It's just one of the features. So imagine you're using a tracking system, and you don't want to put markers everywhere outside. You can now have markers on the LED screen. In this case, we're using red spy markers. You can, of course, change the distances, you can change the seat, you can do all that. But these tracking markers are basically sent directly to the LED panel in only one of the frames. So that means you can synchronize your tracking system to the frames, you see the markers, and you have your main camera in a clean feed, which you should see on one of the monitors. On that one. So that one is clean, there we see the markers. Well, the tracking markers basically, they give you an accurate overlay for what you do, so you can do camera rolls, you can do all kinds of things without worrying to put your markers somewhere externally. We can also now do with 3.5. We can do custom markers. Custom markers can be the following. I'm going to that slide and switch to my presentation again. So just imagine I'm the presenter for the weather today. I'm from Germany, so I have no idea where the states in America are. So I asked my director, if he can please show me where the states are. So now I know, okay, Oklahoma has very, very good weather. Texas is down there. I know all that now because I can see it on the LED screen. But my clean feed for the camera, which is being broadcasted live, will not see that. They should be hidden. So I believe this monitor is showing me the hidden, showing me the clean feed, and this monitor should show me my custom markers. Which is great because it gives me a lot of flexibility. So I can have also arrows. I can have a queue on there, so I could trigger this with our API and can send commands very fast and images very fast to actually have a queue, or all kinds of creative things are possible. We just show that because it's an easy, understandable thing. Another interesting thing is, can you change it to a green screen, please? So now we want to do a production where we do a live feed in the background at the same time like we do a green key. So means you can still decide in post that you want to have another key, that you want to have another thing. It's very useful for virtual production in general, for broadcast applications, even for shooting movies. I mean, with this camera now you can have a shot with your on-scene VP stage, and at the same time you can still use your standard workflows and do a the green key insert afterwards. Well, that's great stuff. That's what we offer just for free in our processes. Once you buy them, you get this as a software feature, which just enabled, no extra cost involved, and it's just coming with all the LED systems you buy, if you buy Brompton processing system. One major achievement we bring on 3.5 is that we could do this all the time with just in overlaying 2 different frames and speeding up the panel on the panel pipeline, but that always comes a little bit with a penalty of that you have to send like much higher bandwidth to a screen, because you need to run, rather than 60, you need to run 120 frames per second, which will basically double your bandwidth. With 3.5, we can do this now inside a same frame time, because we can load the markers, we can load tracking markers or hidden markers, or what I just showed you. We can load it onto the receiving card, and we can use the readout time of the sensor. So we can specifically say, okay, only display my markers in a very, very short moment of time when the camera sensor is closed, so you don't see it. That brings you ultimate flexibility and doesn't bring any penalties on your signal bandwidth. Last but not least, one of our newest features, which we have actually launched last year on ISE, and where we won an NAB award last year, is TrueLight. TrueLight tailors the ability to use 4 emitter LEDs, so RGBW LED panel, which give you a much broader spectral illumination, and it's being enabled by the technology we call TrueLight. So if you just look at me, I'm standing here, I'm illuminated by the scene of about 6 LED tiles. This is rather low pitch LED tiles, but they're bright, so they almost act like a lighting device. What I can do, this is run RGBW, so this is run on 4 emitters now, so you see the color reproduction is natural to the scene I'm standing in. And you can also see the color checker chart, the white is perfect, the colors look pretty good. This is looking good because it's run by RGBW. I just press this one button and we switch to RGB. So now you should see, if I toggle it, you should see a difference in the reproduction of white or in the reproduction of my skin tone, the skin color. You should see that if I go to RGB lighting, it's just incorrect. It's just not the right thing. It's just not looking as accurate as it could be. I think I switch back to my other demo because this probably gives you a little bit better idea. A little bit better idea because the light is much more wider. So you see now here I have very precise colors as you want to see them. This is what I get with RGBW. See, my skin tone is natural. It looks as it's supposed to look in this specific scene lit by a gray, white light. If I turn on or if I turn off RGBW, if I go to an RGB lighting as in the traditional lighting volume, it looks like that. You see the colors wash out. My skin tone goes a little bit reddy, so it's just not correct. This is what you can also have with Brompton Technology, because it's a built-in feature in our processing system. These panels are run by our new receiving card, the G1, which you can see over there. This is the card which won the NAB award last year for the technology we created to bring you this specific calculation power in our system. The NAB award is there. Our other awards are over there on this side, so you may want to have a look at the Lumiere and at an Emmy Award. If you've never seen one, it's a perfect chance to have a look at this. This is what we want with our technology, and you can have that in your TV studio, in your VP environment with Brompton Technology. Thanks for listening, and have a good show.